Okay, welcome to Chapter 2, where we are going to get into the trenches with color temperature. This is the mother of all color theories. You have to understand this. If you understand this, you can paint with color. We're going to gain a lot of seminal things in this chapter. We'll get a deeper understanding of how color moves. That's taking off from Chapter 1. We'll further explore the idea of color movement. An understanding of how light influences, even bullies, color. Strong reasons for our color choices. An appreciation for nature's color theory. You know, how color works in real life. A system of color we can exaggerate for artistic purposes. And because value is always part of the conversation, we'll develop an important link between color and light and shadow. Alright, so something everybody, even my 18-month-old daughter, knows about color is color names. Red, yellow, green, orange, blue. These are also called hues. It's fine to know these names, of course, but they're not very useful. The reason they're not very useful is they don't tell us anything about that color's temperature. When I say temperature, I'm talking about whether a color is warmer or cooler in context. So here's an example of a context. Two red swatches. Those are both red, but they're not the same red. So the usefulness of the word red is immediately hitting its limit. It can't differentiate between these two swatches, but our eyes can. I would suggest to you that this red is the warmer of the two. So here's a different color wheel. Well, it's the same color wheel, except this one only shows us hues and not different levels of grays and saturation. And if color is always moving, I like to think of there being two train stops on this color wheel. The warm stop, which is this range in here, and the cool stop, which is this range on the opposite side. Anything in between those colors, I just think of as train tracks between those two stops. So color is moving around this color wheel, and as painters, we need to track which way it's going. Here's a list of some basic hues again: red, yellow, green, blue. On the left side, I'm going to show those colors in transition toward the warmer color temperatures. And on the right side, I'm going to show those colors in transition to the cooler temperatures. So starting with the warms, as each color travels toward the warm part of the color wheel, let's look at how, as each color gets warmer, how it's being pulled toward the warm part of the color wheel. Starting with red, red is going to travel through the oranges to be in the warm part of the color wheel. So you can see in the red section at the top, you can see how red is slowly sliding into orange, okay? So when we say a warmer red, it's somewhere in that range. Okay, so look at yellow. In order for yellow to stay warm, it's also got to go toward the oranges. So you can see that yellow slowly is in a process of sliding toward orange, which of course then slides toward red, and that's the warmer end of the yellow spectrum. Now look at green. Now we're moving away from the warms a bit. Green is somewhere in the middle, right? So for green to go towards the warms, it's got to pass through yellow and then orange, right? It's going to go in that direction. So greens are warmer as they get yellower. Now with blue, blue is interesting because it's on the opposite side. So for blue to get warm, it's got to travel through the whole color wheel, right? But which way is it going to go? I would say it's going to go into the area that takes it into reds the quickest. So it's not going to go through greens. I would say it's going to go through purples. It's going to go that direction because purples are influenced by red, and red is a stereotypically warm color, as we've established. So for me, a blue can get warmer by traveling through purples, then magentas, and then of course it's into the reds. Okay, now let's look at the cooler temperatures. And of course, just the opposite direction happens. Red is sliding away from oranges, and therefore it's getting into the purple end of red. So when I say cooler red, I'm generally going to be talking about reds that are on the purple side of red, okay? Yellows, same thing, it's going to go the opposite way. It's going to travel toward the greens, which travels into the blues, right? So a yellow can actually start getting greener as it becomes cooler. And a green is going to get bluer, and a blue is going to probably go, well, if I said a blue is going to get warmer by traveling into the purple families, it's going to get cooler by going the opposite way. So it's going to go into the turquoise and cyan families. So the takeaway here is whenever you're using a color name, it's hue, red, yellow, green, blue. You have to precede it with a modifier. Is it a warm red or a cool red? You need to know as the painter which direction it's traveling. So now that we have the beginning of an understanding of what I mean by color temperature, we can ask the question, what drives color temperature? What tells one color which way to move, cooler or warmer? The answer to that is it's dictated by the light. Now, don't worry, I'm going to do a demo for you in just a second, but for now, just as colors can go warmer and cooler, light sources are also going to be either warmer or cooler by nature. So the first step of any study in color is to determine what temperature the light source is. And here's a few common ones. Of course, sunlight's probably the most common light source you'll ever paint. That color swatch, by the way, is just there to show you the general color and temperature of the light, kind of this warmish yellow in sunlight's case. Then you have a tungsten bulb, which is kind of a little more orangey. Tungsten bulbs are the common light bulb you probably have around your house. Firelight, which is more red, and a candlelight, which is sort of in between orange and red. Then on the cool side, a very common one would be overcast or cloudy day. If you just think of a cloudy day, the clouds are like this steely cold gray. You have fluorescent bulbs, which is kind of a green that's airing on blue. And then, of course, moonlight, which is a pretty bluish light. Now, of course, this is not an exhaustive list. There are way more light sources than that, but these are just some very common ones that you'll find yourself painting over and over. The next logical question to ask from here is, okay, so I know what my light source is. What information does that tell me? It tells you which direction, as in warmer or cooler, which direction the colors are going to travel in the light and shadow families. The color of the light opens the floodgates for you to determine what other colors are plausibly going to occur in your painting. Let's take a look at this in practice. This photograph is no work of art, but it does show a basic truth about how color temperatures work in sunlight and in shadow. And I want to show you a very effective, quick, and easy method of studying color from photographs that will help give you some first-hand information on how color works. So I've got the image in Photoshop, and the reason I'm using this picture is because it's very clear what's in light and what's in shadow, right? The shadow is just bisecting the picture right in half. So I make a little chart at the bottom, and I simply begin sampling, and with a brush I paint what I sample from the light in this case. I just paint it as an abstract palette underneath the light. Very simple. There's no thought involved. Just whatever the light is hitting, which is very obvious in this case, sample it and paint it under the light category. And then in just a second, we're going to switch to shadows and do the exact same exercise. Make sure you sample over a variety of materials. So the rock, the trees, the scaffolding, the bridge, the masonry, like whatever is in your photo, make sure you get a good sampling of all the materials that are in there. Then when you're ready, you can go ahead and switch to the shadow side. And just like in the light, make sure you accurately sample everything you can find that's in the shadow and place it under the category. This is not we're not doing any analyzing or thinking yet. We are just sampling colors and putting them down. And this is going to give us a basis from which to observe potential patterns. And I will show you from here how you can actually glean a whole lot of valuable information. So right now I'm just busy. There's a few more things in the shadow here. So I'm just busy sampling from different trees, you know, the cars, the road, the rocks, and the lichens growing on the rocks, and all these little interesting materials that exist in shadow. Now, I'm fully aware that this photo is overexposed. It doesn't matter. We're still going to be able to glean useful information from it. Now that that stage is done, open up a color window like this, and you can spread it right over the photo. I don't care about the photo anymore. I'm just going to start sampling from what I've selected from my light and shadow families. So here's some greens that I sampled from the light. And now I want to start thinking, okay, I want to start noticing where these greens are. I have like 5 or 6 different swatches of green. And as I sample them, you'll notice that the color wheel is stuck in this area. Okay, look again. I'm sampling greens right now. Look at the color box here. I'm sampling greens, and look at where the color wheel is. It's in here, right? Okay, I'm going to start sampling some oranges, like some of the dirt or, you know, sticks and twigs and stuff. Sampling. And you can see that the color wheel is kind of stuck in here. Okay, and the greens were just up here. It's very close. The color wheel so far been stuck in here, and I've sampled like 2 or 3 different materials now. I'm gonna just sample everything in the light. Okay, look at my color box and look specifically at the color wheel. Don't even look so much in here. Look at the color wheel. And well, in Photoshop it's a color strip, but look at the. I'll call it a color wheel. Look at the color wheel as I sample in light. Look at that color wheel. Note how it's stuck. It's like pinned to one small area of the wheel, and not coincidentally, that area of the wheel happens to be the same area that I said earlier was responsible for the warmer part of the color wheel. It's all in this part, right? Now, That brings up a principle of light that I want to direct your attention to. The light source in this photograph is clearly the sun. Now, one of the properties of a light source, especially one as strong as the sun, is, I actually like to call it, it's like a bully. The sun, or the main light source, wants to take every color that it hits, and it wants those colors to conform to it. It wants to pull colors in towards its influence. That's why when I'm sampling all these colors that are in the light, therefore colors that are being affected by the sun, they are all hovering around where I said the sun's color was, which is, around here. They're all hovering here. The sun has taken all of these colors from all disparate materials, right? And has bullied them to be like it. It wants it to be like itself. So let's call that the bully principle. The light source wants every color it hits to be more like itself. And this is actually a principle that you can apply to any light source. And of course, we're going to do more studies after this. But in this case, the sun is such a strong bully that it's taking plants, leaves, rooftops, asphalt, and it's conforming everything to its general realm of influence. So if we're painting this picture, every color the sun hits, we know which direction on the color wheel it will be traveling. Okay, so let's start sampling in the shadow family. And just like before, I'd like you to take a look at the hue wheel more than anything, the color wheel. As I sample in shadow, I'm kind of picking materials that were like the road, the asphalt, the stone, the cliff in the background. Here's some greenery from the trees, actually. Back to the road and stuff like that. And you'll notice, predictably maybe, that these colors actually are on the opposite end of the color wheel. In other words, where the cooler family of colors lived. This illustrates a very simple truth about how light interacts with color temperature, and that is, warm light will produce cooler shadows, and as we'll see very soon, the opposite is true. Cool light produces warmer shadows. Now, why is that? The reason why, in this case, warmer light is producing cooler shadows is simple. It's because the light and shadow are receiving light from two completely different sources. The light is receiving light from the sun, and as I've said, the bully principle bullies every color to be more in the warmer temperatures. The shadows are receiving light from everywhere else. Remember back in values we talked about reflected light? Now what was reflected light? If you remember, reflected light was when light came in from the sun in this case, and bounced off of an object and bounced into the shadow. The shadows are getting secondhand light from everywhere. And if you remember from our value lesson, that secondhand light could also come from the environment, or in this case, the sky. Actually, in this case, that'd be first and foremost. The sky is a 360-degree bowl. The sky is shining blue light down on everything. Now, you might wonder then, why isn't it blue in the sun? And that's because the sun is more powerful. The main light source is the most powerful source in the picture, okay? So you can't have the blue of the sky compete with the sun. The main light source is the bully. Nothing else competes with it. Remember, there is no reflected light in the light family. In the shadows, though, the shadows are free of the bully. Therefore, many more colors may occur there. So you might have the light from the sky, like I said, coming down and making the road bluish, making the asphalt here bluish. Also, what happens is that blue light coming down from the sky, if you take a look at the greens, take a look at these greens here, you notice how when I sample these greens, they're subtly different. They are moving toward blue. Remember, if I go back to the light, here's the green in light. Okay, here's green in light. Notice it's moving toward the warms. If you remember our diagram from earlier, that green is moving toward the yellows, so it's a warmer green. Look in shadow. In shadow, it's moving toward the blues. Okay, they're going in two different directions. It's the same green, it's the same tree, but the color temperatures are moving in two different directions because one is being bullied by a warm light and the other is being influenced by a softer, cooler skylight. Okay, so it only stands to reason that the light family is going to be in a completely different realm of color temperature than the shadow family. Another way of saying it would be the cooler shadows are cooler because they do not contain the influence of the sun's warmth. The sun is not bullying them, so how could they possibly be as warm as anything that is bullied by the sun? The shadows are going to appear cooler just by default.